I'll start it with this. The topic. So firstly, I will describe the what is function app. So the function app is a serverless compute service provided by Microsoft Azure. It allows developer to deploy and run small pieces of code called function without managing the underlying infrastructure. And Azure Function App will provide functionalities like serverless computing, in which it allows developer to focus solely on writing code to handle specific tasks or respond to events. Secondly, it is event driven, in which function in Azure Function App can be triggered by various events, including HTTP requests, timers, schedules, etc. Third one is scalability, in which it ensuring that your function can handle varying workload efficiently. And fourth one is pay per use, in which Azure Function App you can only pay for the resources consumed by your function. And fifth one is language support, in which Azure Function App supports multiple programming language including C Sharp, JavaScript, Python, PowerShell, and Java. And in integration purposes, Azure Function App seamlessly integrates with other Azure services such as Azure Storage, Azure Cosmos DB, Azure Service Bus, Azure Event Hub, and more.
Hello. Hello, Anurag.
Yes.
Yeah, Anurag, are
And
you presenting your screen?
yes, I am presenting my screen.
I'm still able to see the first page. So, are we on the first page only?
Yeah, I am on the first page only.
Oh, okay, okay.
Yeah. And the last point is it will provide the flexible deployment. In Azure Function app provides multiple deployment options, including deployment from Visual Studio, Azure DevOps, Azure CLI, or directly from source control repositories like GitHub. And so further moving ahead, uh, I will start with the agenda of today's knowledge session after the Azure Function app described. So the topics are introduction to exception handling, why exception handling matters, types of exceptions in function app, types of exception handling in function app. Then it's fifth one is security consideration, and the last one is the code demo. So firstly, I will start with the introduction to exception handling. What is exception handling and why it matters? So exception handling is a mechanism to handle runtime errors or abnormal situation that may occur during the execution of a program. Exception handling allows the program to continue its normal flow or terminate gracefully without crashing. And why it matters is the importance of the exception handling is the process of dealing with unexpected or exceptional situation that occur during the execution of a program. In .NET, exceptions are objects that represent errors and they are thrown when an abnormal condition is encountered. Properly managing these exceptions is vital for creating stable and reliable applications. Can I move ahead?
Yeah, sure.
Yes. So now we are discuss the impact of unhandled exception on application reliability in function app. So the first point is application stability. Unhandled exceptions can cause the function app to crash or become unresponsive. That leads to downtime, disrupting the services provided by the application. The second one is the data integrity. If an exception occurs during the processing for data within the function app, it can lead for data corruption or loss. For example, if the function app is responsible for processing transaction, an exception could leave the data in an inconsistent state, leading to inaccuracies or even data loss. Third one is resource leakage. Some exceptions may not be properly handled, resulting in resource leakage. For instance, if the function app fails to release database connection, file handles, or other resource after encountering an exception, it can lead to resource exhaustion over time. The fourth one is security risks. Under unhandled exceptions can expose sensitive information about the application's internal, such as stack traces or error messages, which could be exploited by malicious actors. For example, revealing detailed error message in the production environment might leak information about the system architecture or underlying technologies. And the fifth one is the customer experiences. Reliability issues caused by unhandled exception can have a negative impact on the customer experience. Users expect application to be robust and responsive. When they encounter any error or downtime, it can lead to frustration and dissatisfaction. The importance of graceful error handling for improving user experiences is enhance user satisfaction and the clear communication, reduce user abandonment, brand reputation, and insight for improvement. Notice that only that it plays exception handling plays a very crucial role in improving the user experience of a function app. Can I move ahead?
Yeah.
Yes. So now we discuss the types of exception in function app. So first is the index out of range exception, in which it occurs when you try to access an element of an array collection or in a string, an index that is beyond the valid range. It typically indicates a programming error and can be handled by ensuring proper index bound validation or using exceptions handling mechanism like try-catch blocks. The second one is divide by zero exception. It occurs when attempting to divide a number by zero, which is mathematically undefined. It is runtime error that can be crash an application if not handled. The third one is out of memory exception. It occurs when a program attempt to allocate more memory than is available in the system. It typically caused by excessive memory usage or memory leaks. This exception indicates that the system has insufficient memory to continue executions and often result in application crashes. The fourth one is system exception. It is a broad category of exception that represent unexpected or critical error of system level, such as memory access violation, hardware faults, or operating system errors. The fifth one is argument null exception. Argument null exception is a type of exception that occurs when a method or function is invoked with a null argument that is not allowed. It indicates that an argument passed to a method was unexpectedly null and the method cannot proceed with the operation because it requires a null value. Null reference exception. It occurs when your code tries to access or use a null object or reference. It happens when you attempt to perform operation on something that doesn't exist, resulting in a resulting in an error. The seventh one is DLL not found exception. It occurs when a program or application attempts to load a dynamic link file but cannot find it in the specific location. This exception indicates that the required DLL file is missing or inaccessible. The eighth one is argument out of range exception. It occurs when a method or function receives an argument that falls outside the valid range of values it expects. This typically happens when providing an index, count, or similar value that exceeds the fall allowable range. Output exception. It occurs when there is an error during the input output operation, such as reading from or writing to a file, network connection, or other input output related operation. It indicates that the program encountered a problem while performing this operation, such as file not found, permission denied, or disk full error. These kind of exception we can mainly or uh, oftenly oftenly get it in our code. So now we can explain the how these exception can be handled. And for that, over to you, Dhruv, so you can explain ahead.
Yeah, sure, Anurag. So, hi everyone. First of all, sorry for being unresponsive in the call earlier. I was facing some network issues. So, myself, Dhruv Sharma, I have total 3 years of experience. So, Anurag, can you? Yeah, sure. So, now we have types of exception handling in function app. So, we have basically four types of exception handling in any function app in .NET. So, first one is try catch binary blocks. Second one is logging exceptions. Third one is custom exception handling, and the fourth one is retry policies. So let's talk about the first one, try catch finally blocks. In this, we can have three different approaches. It's up to us. We want to use finally block or not. So, but for a better approach, we should use the finally block. So first, talk about try block. So it contains all the code that may throw the exceptions in our code base. Second one is execution of code begins here. If an exception occurs, control moves to the catch block. So basically, all the code base in which we can have any error or we can have any exception, we put that code in the try block. And if we get any error in that line of code, then the execution will go to the catch block. So catch block follows the try block, handles exception through within the try block. And the third, code have multiple catch blocks for different exception types. So we can basically have different types of we can have multiple catch blocks for a single try block. We can have different type of exceptions in in a different catch blocks. Third one is binary block. It's optional block after catch block. It always gets executed regardless of any exception or not, and useful for most executed code. So basically, in the finally block, we put all the code base which needs to be uh, disposed. If we are using any variable which have a scope of a single function of that function only, then we can put that variable. We can dispose that variable in the final block. So the second one is logging exception. So basically, logging exceptions is crucial for effective error management and debugging in software development. It involves recording information about exceptions that occur during program execution for analysis and troubleshooting purposes. And the importance of logging exception is first one is error diagnosis. In error diagnosis, logging exceptions provides valuable insights into the circumstances under which error occur. And it's also aiding developers in diagnosing and resolving issues efficiently. So basically, if we are getting any exception, it's a different approach to handle the exception, and its error diagnosis is one of the importance of logging exceptions. And the second one is troubleshooting. Detailed exception logs enable developers to reproduce errors and identify patterns, making troubleshooting more effective and reducing resolution time. So basically, it helps to developers to troubleshoot the problem. Where do we get any particular exception of error, and we can basically log all the exceptions and all the messages in our application. Third one is performance monitoring. Monitoring exceptions over time helps in tracking the stability and performance of the software, and it also enables proactive measures to improve reliability. So this is about the logging exceptions. Third one is, so we do have many best practices for logging exceptions. First one is include context. Log relevant contextual information along with the exception, such as timestamps, user actions, and system state to facilitate through analysis. So in this one, we just try to include as more as data or information to log like we are getting any, for example, we are using any API. So in that specific API, we can log the exceptions and the parameters which we are getting in the API, and the certain steps, and so that we can track the exception basically at which level we get that exception. Second one is severity levels. Assign appropriate severity levels to logged exception. Example, info, warn, error to prioritize, and categorize issues for timely resolution. So basically, in this exception, while we log the exception, we can basically log the messages in different forms. We have different types of logging the exception. We have log.info, log.warning, log.error. So any info specific to any API, that info will be logged by log.info. And if we are assuming any error to any specific part, then we can log that error by log.error, and any warning by log.warn. And after that, consistency. Follow consistent logging conventions and formats across the application to streamline error tracking and analysis. So this is also a best practice. And after that, secure logging. Ensure the sensitive information is not exposed in the exception logs to maintain data security and compliance. So in the logs error, avoid to avoid to put any important info about any organization or any or our data. So that no one can get that secure data or something like that. Or, yeah, so these are the best practices for logging exceptions. Uh, Next one, we have custom exception handling. So we can so custom exception handling in .NET allows developers to define and use their own exception types tailored to the specific requirement of their application. So in this exception handling, we can also create our custom exceptions. So what error message or what message we want to show in any particular exception. So basically, importance of custom exception handling. First one is domain specific errors. Custom exceptions enable developers to represent domain specific errors, making error handling more meaningful and effective. Second one is centralized error management. Centralizing error handling logic within custom exceptions promotes code organization and maintainability. Third one is granular error handling. It provides the ability to define and handle application specific errors with precision. And the last one is enhanced readability. So custom exceptions with descriptive names and clear hierarchy improve code readability and maintainability. So by these four ways, we can improve our custom exception handling, and we can improve our readability of our code base, and most importantly, error error handling. So next one is fourth one, and the last one is retry policies. It's also a part of exception handling. So retry policies in .NET provide a systematic approach to handling transient failures by automatically retrying failed operation with configurable strategies. So in this exception, we put a specific retries by configuring in our application. So if we are getting any exception one time, so we can put a retry failed operation so that the execution flow retries that operation. So importance of retry policies. First one is resilient applications. Uh, Retry policies enhance application resilience by mitigating the impact of transient failures such as network issues or temporary service unavailability. Second one is improved user experience. So retrying failed operations reduces the likelihood of user facing errors and improves overall application usability. Third one is customizable strategies. So in this, developers can tailor retry policies to specific scenarios, adjusting factors like retry intervals and maximum retry attempts. And the fourth one is define retry policies, how we can define and create reusable retry policy objects with configurable parameters like retry attempts, delay intervals, how many retry attempts will be there, what would be the interval between uh, two attempts, and error conditions. So the last importance of the retry policy is circuit breaker integration. So in this, we have combined retry policies with circuit breaker pattern to gracefully handle repeated failures and prevent excessive retries. So these were the basically four exception handling approaches in .NET. So can you, Anurag, now security considerations about our function app. So secure exception handling practices are essential to prevent information leakage and protect against potential security vulnerabilities. And it also includes avoiding exposure of sensitive information in error messages, implementing authentication and authorization mechanisms, and conducting regular security audits. So we have some best practices for security considerations. First one is avoiding exposure of sensitive information. So we should always try to avoid the sensitive information, prevent accidental exposure of sensitive data in error messages or logs. The same thing which we discussed in the custom logging. So we should try to avoid the mentioning or using the sensitive information. And second one is implementing proper authorization and authentication. So it ensures that only authorized users can access function endpoints and data. So in this, basically, we add the authorization and authentication to our function app. So basically, we also authorize the APIs. So we can add the authentication on our different um, APIs on the basis of tokens. So uh, everyone every user which have that a specific token can only use that, can only consume that API. And third one is regular security audits and monitoring. Identify and mitigate security vulnerabilities proactively. So these are all, these are our best practices for security perspective. And also we have a note for this. By following these practices, function app can handle exceptions securely, protect sensitive data, and maintain a robust security posture against potential threats and vulnerabilities in our application. So this was about the security consideration. Now the next part is our demo to show the code specific to this. So let me share my screen. So is my screen visible?
Yes.
Okay. So in our code base, we have added the code for the different exception handling approaches. So here comes the first approach, try catch exception. In this, we have added the try block, like the code base in which we can have any exception or we can have any error. So we put that code base into the try block, and following that we have a catch block. And in the cat this catch block is of a divide by zero exception type. So we can also put here different more catch blocks specific to different exception types. And we can also put the main exception type here. So if none of if the program flow not going to any of these blocks, so then it will goes to the main exception block. It is generic, by the way. So but the main thing is we have if we are writing these specific types exception, we should um, we should write them before the main exception type. Otherwise, if we put this section before the divide by zero exception catch block, then the program flow uh, gets catched into this exception, and we will get an exception occurred error in that case. So following that, we have a finally block, and finally block always gets executed whether we are getting any exception or not. So this is about the try catch exception. After that, we have custom exception. Um, in this also, we put that code base in the try block in which we can have any error or exception. Sorry, exception. So like we have created a custom exception here, and we have defined that my custom exception down below here, and we can put any exception here, specific type of exception which we want to show in our application, which we want to return in our application. And following that, we have a catch block, and the program flow will always get into this exception block. After that, we have this type of exception block. So this is about the custom exception one. And the third one is logging exception. In this type of exception handling mechanism, we the same way we define the exception, we define the code base in which we can get the exception in the try block, and the same following with the catch block, and we are returning through here. So let me just run this code quickly. So we have exception handling control here. First one is our try catch block. So we are basically using the divide operation in this try catch block. So basically we are using 10 by a divisor. So if we are inserting 2 here, so code will get executed, and we are getting 5 as an answer, and status code 200. But if we are putting 0, and we add a debugger for better understanding here. So execute this. So like now we are getting divide by 0 exception in this case, because we can't divide 10 by 0, and we'll get the divide by 0 exception attempted to divide by 0. We are getting this exception on the Swagger. And by this try catch, we can also use any other exception type like we discussed in the earlier in the slide. So second one is custom exception. So just hit the second one, custom exception. Right, execute this. So in this, we are throwing an exception from here to my custom exception. So the program flow will get to the catch block after this one, and this one is also of my custom exception. So we created this class by my custom exception. We created this function, my custom exception, and so after continue, we will get this error message which we customly added there. So this was about the custom exception, and after that we have logging exception. So in this, the same approach, let's just step over. So here we also throwing the exception, and we can also, we are in the exception, we in the catch block we are logging the error, like we are logging the exception which we are getting from here. Simulated exception occurred in the method, and which followed by an error occurred while executing the do work method. So in this logger.log error, the if we are using any console application, then this error will get printed to the console. But here we are not using console application, so we'll get true in the result. So this was we are getting in the result. So this was about our coding section, and we covered three of the main exception handling approaches. So this was all about the coding section. So any doubts regarding to these types or anything else? Anyone?
Guys, do we have any questions?
Yeah,
Over
one
to-
question. Yeah, that DLL exception that you were talking about, that is specific to .NET only?
Yeah. No, that's not specific to .NET only. If you are using any other language if you are using in any other language, we'll also get that exception.
Okay.
If you are using any DLL, and but if that DLL is not present at that location, so we'll get a runtime exception in that case.
Okay.
Yeah. So over to you, Anurag.
So, yeah. So the summary of this session is that the exceptional handling is not only about catching errors, it is about handling them intelligently. By understanding the intricacies of exception propagation, developers gain insight into how error propagates through their code, allowing them to design comprehensive error handling strategies. Custom exception classes provide developers with the flexibility to define specific error types tailored to their application needs. These custom exceptions enhance code readability and enhance more precise error reporting, ultimately improving the debugging process. Furthermore, exception handling extends beyond mere error detection and recovery, and the documentation of the application plays a vital role in exception handling, guiding developers through the error handling process and providing insights into potential error scenarios. Clear and concise error messages aid in troubleshooting and debugging, facilitating facilitating quicker resolutions of issues and enhancing the overall user experience. So, in conclusion, the effective exception handling is a cornerstone of robust software development. By mastering exception handling techniques and incorporating best practices into code bases, developer can build resilient systems that instill confidence in users and withstand the challenges of real world usage. That's all from my side.